Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to be talking about the case of the missing diagram. We are going to be reading semi-word problems. I guess you can call them word problems. They're going to give you information, and we are going to be responsible for actually setting up the proof. That means we're going to be responsible for listing the givens, listing what it is that we're trying to prove, and of course, drawing out the diagrams that are going to help us prove what we need to prove. So it's a pretty unique lesson. A lot of thinking here, but I know that we will succeed, and I know that we can do this. So all right, guys, let's try to knock this sucker out. We're just going to hit right to examples. That's the good thing. We don't have to learn any new theorems per se in this lesson. All the theorems that we've learned so far are going to be combined together. So let's get right to it. Example 1, set up a proof for the following statement. Notice, I did not say prove it. I just said set it up. You're going to have some questions on the quizzes and the tests and the homework that's going to just say set it up. And then you're going to have some that's going to say set it up and prove it, okay? But I think that the most important part here is being able to set it up, understand what the givens were, understand exactly what it is that you're trying to prove for, and of course being able to draw the figure. So it says here, for example 1, if two altitudes of a triangle are congruent, then the triangle is isosceles. Okay. Before you get into any of the givens or what you're trying to prove, I always draw the figure. So what are we trying to prove here? What kind of a triangle are we trying to prove here? That it's an isosceles, right? And what's within these isosceles? The altitudes. Now you have to remember what an altitude is. Remember that an altitude comes from a vertex and creates a 90-degree angle with the opposite side of that vertex. So I'm going to go ahead and draw my isosceles triangle with two vertices. You can label the letters anything you really want. I like to stick to A, B, C, D. I go in that order. That's just me. You could do what you want, though. I'm not going to restrict you. But for me, personally, it's easier if I just go A, B, C, D, E. Okay, and what we have here is very clear. I tried to draw an isosceles triangle, and I made two altitudes. Now, you may be thinking, Mr. Morrow, how did you know to draw the altitudes from the vertices that you actually drew them? Why didn't you draw an altitude from here, Mr. Morrow? Here's my logic, okay? If this is an isosceles indeed, aren't AC and AD congruent then? Okay, so it would make sense to me that the congruent sides, since they have congruent angles as well, the altitude should come from those congruent angles, because here is where I'm going to create my 90. Now the question may be, will it work if I come from the vertex? No, it will not. Okay? When you're trying to prove an isosceles and you have medians or you have altitudes, in general, go ahead and create that altitude or median from the base angles. Yes, sir? And then your second, my brother. Yes, okay, good question. That's why this is such a good and challenging section. What my boy just said was I drew two triangles. No, if two altitudes of a triangle are congruent. So thank you for that catch. Yes, sir. Yes, sir. This would be 90, right? And this would be 90, correct? This, okay. This is not, no, you don't have to assume that at all, but great question. We're actually going to get into a theorem for that tomorrow. However, right now with what we have, if this guy here is 90, right? Isn't this supplementary? So if this is supplementary, and you take away this 90, what am I left with? The other 90, because 90 plus 90 equals 180. Well, you would have to say, in this case, angle ABD is supplementary to angle CBD, right? Because if this is a 90, ABD is supplementary to CBD, correct? This is supplementary. That means this has to be a 90 because of subtraction property. Does that make sense? Thank you. We're going to learn tomorrow that that's actually called the right angle theorem. Okay? Not the right angle congruency theorem. The right angle congruency theorem states that two right angles are congruent always. We're going to learn tomorrow the right angle theorem, but I don't want to get there yet, okay? So I have my drawing for my triangle. Let's see what I was given. What did they give you? What did they tell you for sure is real here? Yes, sir. Thank you. You have two altitudes, and they're congruent. So I'm going to first say that BD is an altitude to AC. Then I'm going to say that CE is an altitude to AD. And then I'm going to say that BD is congruent to CE because those were my givens. And I kind of jumped the gun. I wanted to wait on the proof. But what are we trying to prove? We're trying to prove then the triangle is isosceles. Because remember what they have here, my brothers. This is a hypothesis. If then statement. The if will always be the given, guys. Always. The then will be what you're trying to prove. So again, the if is always the given. The then is what you're trying to prove. Okay? Does that make sense, guys? Yes, sir. Yeah, it's kind of like the reverse of it's like undoing a paragraph proof. Yeah, well put. I like that. Now, I promised you that we're not going to do the proof for this one, but let me just run it down with you guys, okay? And actually, let me do something real quick. Okay, thanks for your patience as always, guys. Okay, so let me just run down the proof right quick for you guys. We know that BD is congruent to CE. And we know that BD is an altitude to AC and CE is an altitude to AD. So basically, we know that this triangle right here, that's a right angle. We know that this triangle right here, that's a right angle. Okay? Those are two right triangles. We know that BD is congruent to CE. So let me just try to see if I could do this the right way in color format. That green is congruent to this green, correct? You with me, guys? And then, hopefully everyone can see that CD is congruent to itself because of reflexive. So that means those two triangles would be congruent because of HL. If they're congruent because of HL, then I can very easily prove here that, okay, let's see here. Am I doing this the right way, though? Would you have to have a point here? No, no, not really. Yes, thank you, son. It eluded me. That's why you guys are awesome. Here, let me just do this in purple. So you have this triangle, right? That purple is congruent to this red triangle. So I would say then that angle BCD, okay, is congruent to angle EDC because of CBCDC. Once those two base angles are congruent, you would know that AC is congruent to AD, hence giving you an isosceles. Okay? Does that make sense? Okay, I just wanted to kind of run through it with you. Yes, sir.
The triangle.
Yes, sir.
We know which triangle we're talking about. We're talking about
Good question. Because it's talking about the triangle from which the altitudes are present. And there's two altitudes from one main triangle, which is triangle ACD. Do you see that? Let me erase this and hopefully that'll make it clear. Because the question was, it says the triangle is isosceles. There's quite a few triangles here. Yes, but it says if two altitudes of a triangle. So this altitude and this altitude came from this triangle ACD. And that's what we're trying to prove is isosceles. Does that help you, sir? It's a great question. Thank you so much. Yes, sir, my brother. Once I found the base angles, I can say definition of isosceles, yes. Because definition of isosceles, two legs are congruent, correct? Or the two base angles, or actually, and the two angles are congruent. If the two base angles are congruent, then the two legs are congruent, and therefore it's isosceles. Correct, sir? Thank you so much, guys. You guys are awesome. Okay, number 2. Just set up the proof for this one as well. Okay, just set up the proof. The medians of a triangle are congruent if the triangle is equilateral. So this time, remember what I said. The if is the given. Okay? So in this case, the if is the triangle is equilateral. So please listen to me when I say this. Draw the figure first. You're talking about an equilateral triangle, and it says the medians. How many medians can a triangle have? 3. Very good. So draw an equilateral with 3 medians. Label it whatever letters you guys want. I'm not picky about that. I would love it if you did it like I did it, you know, A, B, C, D, E, F, G, H, I, etc., etc. Bless you. But that is not a prerequisite. I'm not going to, you know, take points away from you if you do different letters. And the given here is that this triangle, ACE, is equilateral. And also, what's given is that AD, CF, and BE are medians. Okay? That's what's given here. And what we're trying to prove is that those medians, AD, CF, and BE, are all congruent. Yes, sir? That would be the given. Remember what I said. The if part is always the given. But remember what they said to you too. They kind of made this one a little challenging. It said the medians of a triangle are congruent. So I'm trying to prove that the medians are congruent, but you know that the medians are there. So, okay, as usual, I messed up. It's not triangle ABC. I apologize greatly. It's triangle ACE. Sorry about that, boys. Apologize. So triangle ACE is equilateral. That's given. This triangle has 3 medians. That's given. What are we trying to prove? I'm trying to prove that these 3 medians are congruent. They're the same measure. They're congruent. So that's what I'm trying to prove. Now this is a bit of a lengthy proof. You have to do a detour on this one. So I'm not going to go through it right now. But this is a great proof that could be a quiz question or a test question. And if you think about it, if they're medians, that means that each of those sides, well, first of all, if it's an equilateral, that means that AC is congruent to AE, which is congruent to CE. But then the definition of equilateral triangle, absolutely. Then BE will cut AC into 2 congruent parts, which would be AB and BC. CE would be cut into 2 congruent parts, which is CD and DE. AE would be cut into 2 congruent parts, which would be AF and FE. Okay? Those would all be congruent because halves of congruent segments are congruent. Exactly what I just said. Division property. You would say AB is congruent to BC, definition of median. CD is congruent to DE, definition of median. EF is congruent to AF, definition of median. You could put that in separate steps or all in one step, whatever you chose. And then you could say AB is congruent to BC, is congruent to CD, which is congruent to DE, which is congruent to FE, which is congruent to AF, because division property. Halves of congruent angles are congruent. Okay? Does that make sense, son? And then you'd have to go from there in a nice big detour proof. Okay? But for now, I just want you to set this up. Does that make sense so far? All right, let's continue. Set up a proof for the following statement, please. The altitudes to the base, and I shouldn't have said plural. It's more the altitude. There aren't altitudes to a base if it's isosceles. The altitude to the base of an isosceles triangle bisects the vertex angle. Okay, again, draw an isosceles and draw an altitude. Now in this case, there's no if. It gets a little bit more difficult. So what can you say here? Well, the altitude to the base of an isosceles triangle bisects the vertex. So I'm trying to prove that this altitude bisects the vertex. But what's given? Well, what's given is that ABD is an isosceles triangle. Okay? ABD is an isosceles triangle. AC is an altitude, that's given. Angle A is the vertex, that's pretty given. And BD would be the base of this triangle, ABD. You with me there, guys? So, let's figure it out. And of course, I made another mistake. It's ABD, not ABC. Sorry, there's no excuse there. Sorry. So I'm trying to prove here that AC bisects the vertex angle BAD. Yes, sir. No, you would have to say is the vertex of triangle ABD because there are three triangles here. There's ABD, there's ABC, and there's ACD. Yes, sir. I did. I say angle A is the vertex of triangle ABD.
There's also angle ABC.
No, there's triangle ABC, which doesn't have a vertex because that's not isosceles. If I look at ABD here, I love your question, by the way. Thank you. There's only one vertex to ABD. See what I'm saying, my man? Now, what you're saying is not inaccurate. Well, I think what you're saying is, Mr. Morrow, couldn't I say angle BAD is the vertex of triangle ABD? Absolutely. Either one would work in this case because you used the triangle. But great question. There's absolutely nothing wrong with what you said. In fact, it's phenomenal. Well done, sir. Very well done. And again, you know it's an altitude because they tell you. Okay? They say the altitude of a base of an isosceles triangle. So they're telling you it's isosceles. So that means you have a vertex, and that means you have a base. Now, for this proof, this was pretty easy. I could draw this out for you pretty easily. You know it's isosceles. So that means AB is congruent to AD. Okay? You know that this is an altitude. So that means that that's a right angle. That's a right angle. AC is congruent to itself, right, because of reflexive. And you know that AB is congruent to AD because definition of an isosceles. So that means that triangle ACB is congruent to triangle ACD, as in dog, because of HL. And then you would know that angle BAC is congruent, as this guy here, is congruent to angle DAC because of CBCDC. And then you would know that AC bisects angle BAD because of definition of angle bisector. Okay? Yes, sir. No. We had to prove, the question was, did we have to prove that triangle ACB and ACD are isosceles? No, we proved that they were both congruent. Let's go through it again. And I thank you. That's what I love when you guys ask questions. Okay. If I know that a triangle ABD is isosceles, right? So I know for sure, 100% guaranteed, that AB is congruent to AD. Definition of isosceles, right? If I know as my given, my brother, that AC is an altitude, then I know that angle ACB and angle ACD are both 90-degree angles, right? I could then say that angle ACB and angle ACD are congruent because of the right angle congruency theorem. Right angles are congruent. Then I could say that AC is congruent to itself because of reflexive property. Now I can say triangle ACB is congruent to triangle ACD because of HL, hypotenuse leg. Then I can say angle BAC is congruent to angle DAC because of CBCTC. Then I can say AC bisects angle BAD because of definition of angle bisector. No, thank you for your honesty. Great job. Yes, sir. Sure. You had to find out that two triangles were congruent before you could get this angle to be congruent to that angle. Right? You had to. Thank you. Great, 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 great. All right. May I continue? All right, boys. Let's do this. Set up a proof for the following statement. If two angles of one triangle are congruent to two angles of another triangle, the remaining pair of angles are also congruent. So in this case, how many triangles do I have to draw, y'all? Two. That's exactly correct. So let's draw two triangles. I don't care what kind of triangles you want to draw. But remember, they're not right angles. They didn't say right triangle, so don't do a right. So you have two triangles here. You know that two of the angles of one triangle are congruent to two of the other angles of the two angles of the other triangle. So, how will we set this up? Me personally, I'm going to say that A is congruent to D and that B is congruent to E. Could you have said that C is congruent to F? Sure, doesn't really matter. That's just what I chose. And then I chose to prove, let's prove that C is congruent to F. Could you have made C to F congruent and B to E congruent and then prove A and D are congruent? Sure. Any combination there. But just make sure that you have corresponding congruent angles. Okay? Now, for this proof, guys, it's actually quite simple if you really think about it. How many degrees are in any triangle? 180. Okay, so if I have two angles that are congruent, doesn't the third one have to be congruent because of subtraction property? Does that make sense, guys? Let's assign numbers to it just for giggles. Let's say that this is 40. That means this is 40. Let's say that this is, I don't know, 80. I'm just making numbers up. That means that has to be 80. Well then, 40 plus 80 is 120. This has to be 60. 40 plus 80 is 120. This has to be 60. So they would both be congruent because of the subtraction property. Okay? And now in our last example, we are going to actually prove the statement. But I see that some people are still writing, so I want to make sure you got this down pat. We're good? All right, brothers. Let's do this. All right. Set up a proof for, comma, and prove the following statement. The altitude from the vertex angle of an isosceles triangle is also a median. Okay? So in this particular case, the is what you're trying to prove. You're trying to prove that the altitude is also a median. So what do we have? We know that we have an isosceles triangle. So I'm going to draw an isosceles triangle. We know it has an altitude from the vertex. So that's why I drew it from the vertex. It was very specific. I want to prove that altitude AC is a median. So the only thing that I know for sure that I was given is that triangle ABD is isosceles, that AC is an altitude, and that's it. That's all I know for fact. I'm trying to prove that AC is a median. So I don't know why I keep messing up with this today. There's really no excuse. It's ABD, not ABC. I apologize. And that's my given. Triangle ABD is isosceles. AC is an altitude. And segment AC is a median. Oh, don't even sweat it, dude. Okay. Now, like always, I drew it out for our proof. And let's start. Our given, which is wrong, of course, because Mr. Morrow is just not labeling his triangles correctly. ABD is isosceles. Bam. That's a given right off the bat. Now, from there, if we know that it's a given, my brothers, we know that AB, very good, my man. AB is congruent to AD. That's absolutely 100% accurate. That is because of definition of isosceles triangles. We also know that AC is an altitude because it was given. But if it's an altitude, then I know that ACB and ACD are right angles. Definition of an altitude. And if those two guys are right angles, we could mention that they're congruent. I'm not going to take points away, but hopefully by now you're realizing, wait a second, I already have a hypotenuse that's congruent. If I just go ahead and say that AC is congruent to itself because of the reflexive property, but because of what I just said, because of the reflexive property, right? And you're absolutely right. Then from there, you're going to have very easy proof that triangle ACB is congruent to ACD because of HL. And then you can quite easily prove that BC is congruent to CD because of CPCTC. And then boom, there's your proof. AC is a median, absolutely, to BD. Why? Definition of median. A median is a segment that generates from the vertex and cuts the opposite segment into perfect halves. And that's putting it all together here, guys. So thank you very much. I hope you learned a lot. Any questions? Have a wonderful day. Thank you so much.